Hello everyone, this is Associate Professor Dr. Görkem Üçtü from Mechanical Engineering Department. You also know me as the coordinator of FENG 497. Today I will be talking about sustainable engineering. As an academic, my main field of study is sustainability with a special focus on energy and food systems. So I work on issues like environmental impacts of processes, life cycle assessment, efficiency. So I will be speaking actually about my own fields of interest in today's video. While preparing this video, I made use of a very nice presentation that has been prepared by a professor in KTU University of India. So some of the slides in today's presentation have been taken from that presentation. So I would like to begin by crediting this professor. So we will begin by showing you some images. The first few of these images will be positive images, such as this offshore wind farm or this very nice house whose roof is entirely covered by PV panels, or this water canal which is also covered by photovoltaic panels, this field which is again covered by photovoltaic panels, or this electric car which is being charged in the middle of the city. So these are very nice, very hope-creating images for our future as humanity. But then there are these images as well. So here you see a beach which is filthy with all kinds of industrial and human waste, or this landfill. This street, which is filled with basically human waste. This area that has been deforested for God knows what reason. And in this image, we see the negative impacts of or industrial processes in the form of dangerous gas emissions, toxic gas emissions, which cause many health impacts on humans. The most notorious of these impacts is respiratory problems. So, what is wrong if mining or sand from rivers is not regulated? When we build bridges, flyovers, buildings for housing or for business in the form of flats or individual houses, what is wrong if paddy fields are filled up and leveled for house construction? What is wrong in using plastic cups for drinking tea or coffee? What is wrong if the highly rich businessman buys an aircraft presented as birthday gift to his wife? What is wrong if I air condition all the 4 bedrooms and the living room in my house? And why should the authorities deny me permission to build a house just because I have not shown provision for rain water harvesting? Now, many of the things that we have seen in these last 2 slides are essential. I mean, we need to especially those of us who live in very warm climates, we need air conditioners in our houses. Or, for instance, we need to construct bridges, we need to construct houses for certain reasons, especially when we are buying coffee from a restaurant, we may need to use plastic cups. So these are things that we may not avoid, but we should always consider that all of our actions have certain consequences. And these actions bear even more importance for us engineers because many of today's problems are directly relevant to engineering activities and again can be partially or completely overcome again thanks to the efforts of engineers. So the questions that we have asked so far should be studied from social, environmental, economic, and political points of view. And when we do that, we need to have a look at this very famous report named Brundtland Report, which was published way before many of you, maybe not many of you, any of you was born in 1983. I was just 1 year old, and none of you were born then. So this report, which was prepared by an initiative of United Nations, UN, provided information about the environmental issues and sustainable development. So some of the major issues that were discussed in this report was how we can promote sustainability, what should developed countries do and underdeveloped, or in this context, poorer countries do in order to tackle environmental issues, sustainability related issues, how we can prevent environmental degradation by considering economic, social, and political factors, how the world can act together, how the world can adopt a global focus and take a positive attitude towards development. So that was the content of this report. And thanks to this report, we define sustainability. Sustainability, as indicated here, and as you will see many more times throughout the rest of this presentation, stands on 3 pillars. So these pillars, as you can see in this slide, are the social ones, economic ones, and environmental ones. You cannot think one without considering the others. So sustainability or sustainable development is development that meets the needs of the present without compromising the needs of the future generations. This sentence has directly been taken from that particular report. That was maybe the first time that sustainability has actually been defined back then, almost 40 years ago, and since then we still use this definition today. So this image summarizes those 3 pillars. I said pillars, but in this figure you see them as circles, and it's not surprising that the environmental circle is on the outermost circle in this figure, because economic and social implications are actually also limited by environmental concerns, or they should be limited or constrained by environmental concerns or limits as indicated in this slide. So if we discuss in more detail, when we say economic issues, we should consider efficiency and productivity with a special focus on energy efficiency. We should consider employment, which is also a source of a social impact as well, revenue generation, access, connectivity and trade competitiveness, infrastructure development, and possible congestion. These are the economic concerns. What about the social ones? Equity and fairness, equality and fairness actually. There's a little typo there, my mistake, I'm sorry. Social inclusiveness and value, community involvement, health, safety, and labor conditions. And what about the environmental concerns? Marine, which means water related, marine, air, and soil pollution, noise, vibrations, and several different impacts on biodiversity. We will discuss some of these in more detail in the coming slides. Air emissions and GHGs, for those of you who don't know what GHG is, it's the short for greenhouse gas, and it's the major cause of climate change, or as it used to be called, global warming. We will discuss that in more detail as well. Resource depletion in the form of abiotic resources and biotic resources for fossil fuels, and land use. So there are many different issues that we need to consider all at once. So we see the same figure now, but this time instead of circles that are within one another, we see them as separate circles. So we have the economy, which means profits. We have the social equity, people, and environment, the planet. So economy, in order to create more, in order to build more, we need to create a domestic product, gross domestic product, GDP. So the economy has to survive. But there wouldn't be an economy without the people, or without happy people, without functioning society. So we need the social balance. And also, we cannot talk about creating anything. There will be no resources without the environment. So these 3 are all equally important, and they should be considered at the same time. So let's discuss these pillars, if you will, in a little bit more detail. So when we say social, we mean equal access to social resources between current and future generations. The most important issue regarding sustainability is it deals with the future. I mean, it's obviously important to save today. I'm not going to deny that. We must overcome income distribution inequalities as best as we can. We must try to improve infrastructure everywhere as best as we can, not only in certain locations, certain countries, but while doing that, we must also always consider the future. We should not sacrifice the future to maximize the benefits of today. That is sustainability. We should always consider the future. So the social resources are, or the social indicators are quality of life, growth, and equality. In the same time, we must make sure that there is a functioning economy, because without a functioning economy, development is impossible. And as far as environmental issues are concerned, we must make decisions and take actions that are in interest of protecting the natural world. Not only to protect ourselves, but also protect the animals and the ecosystem in general, because although it may not be easy to realize, we all depend on one another. I mean, animals, plants, humans, we all live in the same environment and we need each other. So what are the challenges that we face? I mean, there are several challenges. You may discuss which one is more important, which one is less important. I mean, I may agree or disagree, but these challenges are surely here. So, first of all, there is a steady increase in population. I mean, according to some scientists, this increase will continue. According to others, we will reach an equilibrium point. We don't know yet, but what we know is for the last few decades, the global population has been increasing steadily, and by just a few, maybe 3 years' time, the world population is expected to reach 8 billion. At the same time, we degrade our lands that could, for instance, be used for more long-term purposes. One example is, for instance, the rainforests in South American countries such as Brazil is unfortunately being destroyed, which is called deforestation, for cattle grazing. Well, I'm not going to deny that cattle grazing is an important part of Brazil economy. So because Brazil is a big producer of and exporter of meat, so yes, they need those areas to feed their cattle, to sustain the meat industry. I'm not going to deny that, but this is an issue relevant to economy. But if we sacrifice the environment for economy, you should remember that in a few years' time, maybe in 10 years, maybe in 20 years, those fields will lose their fertility for good, and they will be useless. They won't be able to be used for any purpose. Therefore, any damage on the environment in the long run will also negatively affect the economy. So if we try to maximize the economic output today by forgetting what may happen in the future in terms of environment in this example, at the end of the day, when that future arrives, we may also lose that economic benefit that we assume that we would always have. Nothing is permanent. Nothing should be taken for granted. Another important issue is water scarcity problems. It's estimated that by 2050, populations living in water shortage areas will increase by 90% compared to today. And this is actually relevant to the next challenge, which is global warming and climate challenge. Climate change, I'm sorry. I'm not going to describe in detail how global warming and climate change take place, the physical mechanisms behind this phenomenon. This is not an environmental chemistry course, but basically climate change, which is the phrase that we prefer today. In the past, global warming was more common, but now scientists have understood that it's not going to be a global warming everywhere. In some parts of the world, the climate may change. The climate change may show itself in the form of a temperature decrease, an average temperature decrease rather than increase. So we prefer to say climate change right now. And plus, when climate changes, it will not just be the average temperatures that will change. Many other phenomena that are relevant to the climate will also change. So, Intergovernmental Panel on Climate Change, IPCC, estimates a minimum of 1.4 and a maximum of 5.8 degrees average temperature change per year by 2000, not per year, annual average temperature change by 2100. So if the temperature increases by 5 degrees on an annual basis, believe me, many parts of the world will become inhabitable because the sea levels will rise so much that many cities, including unfortunately our city, Izmir, will become inhabitable. So to avoid this, we must minimize the average temperature increase. Unfortunately, it's not now too late to take it back. We won't be able to undo the temperature change, but the next challenge that we face is to minimize it. 1.4 or maybe a maximum of 2 degrees is what we should aim. We should not go above that value, otherwise the consequences will be extremely harsh. At the same time, there's an increased energy demand, which is good and bad at the same time. Now that there are new technologies being developed everywhere in the world in different fields, in health systems, personal electronic devices, transportation, etc., etc. We have a more comfortable life, and certain technologies and services now can be presented to people or populations that in the past could not access these services because of a lack of opportunity. But these new services also require energy. Therefore, more and more people will need more and more energy every year. And unfortunately, most of the environmental problems actually are caused by energy demand, especially in the form of fossil fuels. So the increased energy demand should be solved, that's for sure. I'm not going to say we should decrease the demand. The demand will increase, that's for sure. As the population increases, as the technology develops, the demand will inevitably increase. We cannot prevent it. But what we can do is we can use more sustainable energy sources such as renewable sources, wind, solar. Maybe we can design more efficient systems that give you the same output for a reduced amount of energy input. With such approaches, we can achieve or we can meet the energy demand without sacrificing the future. Poverty is another challenge. It's been an ongoing challenge since the dawn of time. Unfortunately, an equal distribution of resources and income has never been possible throughout human history, and it's not possible today. But again, by providing incentives to disadvantaged populations, especially in parts of the world such as Africa, in certain parts of Asia, we can, I'm not going to say overcome, that would be too ambitious, but we can reduce poverty. And final challenge that we face is unemployment or underemployment. So when people don't have any jobs. I mean, this is also relevant to population. If the population of a country increases too much without the resources increasing at the same rate, then as time goes by, more and more people will be unemployed, unfortunately. So in order to achieve this sustainable development, we must try to overcome these challenges as best as we can. This is what the Brundtland Commission report stated in 1987. But that report was also criticized from certain aspects. Some people suggested that it has a very limited focus, and it only focuses on what poor nations should do to become richer. So in order to increase the focus, in order to see this big picture, as we say, we must consider the needs of today alongside the needs of the future generations. So we must always ask this question to ourselves. What do we need now? And what will be needed in 10 years from today, 20 years from today? For instance, when we are trying to meet the energy demand of today, we should also consider what the energy demand will be in 10 years or in 20 years. And we should build the infrastructure like that. Otherwise, speaking of sustainability will be completely meaningless. So, as we have mentioned earlier, the sustainable development has 3 basic components. So let's discuss them again in more further details. So the question of ecology, natural resources, and global changes. Now, in the past, energy consumption did not have too much effect on the ecology, but nowadays Now technology advanced and humans grew beyond control, as mentioned earlier in the challenges slide. We cannot overlook the impacts of these advances on the ecology. From a social point of view, the question of solidarity and justice between present and future generations and between developing and developed countries should be considered. And we should always not forget the importance of economic growth, regulation, production, and consumption. So what is sustainable engineering then? Sustainable engineering, first of all, I should underline that it is not a separate discipline of engineering. There is no sustainable engineering bachelor's degree. There is no sustainable engineering postgraduate degree. No matter what you are, you can be a civil engineer, you can be a computer engineer, you can be a genetics and bioengineer. It doesn't matter what you study. You must make sure that you learn the principles of sustainability and you apply these principles in your practices. This is the role of the future engineer. That is especially important. That is, as I told you earlier, because most of those challenges are caused by engineering activities, directly or indirectly, and can be overcome or reduced by, again, engineering activities. Sustainability is important during design, during utilization, during production. So at different stages of engineering processes, we must always consider sustainability. So, and this has been acknowledged by United Nations in 1992, almost 30 years ago. Sustainable development will be impossible without the full input by the engineering profession. So, no matter what we design, it could range from transportation to toilets, from pest control devices to electronics. We must make sure that we consider the sustainability. We must consider the social impacts, the economic impacts, and the environmental impacts. The most important are fossil fuel-based products and services. You cannot limit this to only one engineering profession. I mean, mechanical engineers work in power production and they are directly involved with fossil fuel use. But in also other fields, such as food engineering, we use fossil fuels a lot. Or in civil engineering, in order to produce cement, you need lots and lots of energy that you obtain usually from fossil fuels. So in many different engineering disciplines, we face this problem. Riverside-based constructions, in river sand-based constructions, it's especially important in countries where water shortage is an issue, and energy consuming processes. Any energy consuming process, no matter what form of energy we are talking about, this could be fossil fuel based energy, this could be electrical energy, we must cut this down to a minimum. If we don't, we increase stress on the world's already limited resources. So sustainability should be at the intersection of environmental, economic, and social indicators or pillars. So there's a nice analogy here. It's a very simple but nice analogy. So at the base, as you can see in that figure, at the base we have the political pillar, which is horizontal, not vertical. And then you have the economic, social, and environmental pillars, which altogether make up sustainability or sustainable future. Without any of them, the system would collapse. So what are the social dimensions of sustainability? So they relate to human values, human relationships and institutions, worker health and safety, quality of life, which can be measured by using different indicators, benefits to the disabled people, protection of human rights, child mortality, which used to be very high, but it's decreasing day by day, especially in modern countries. In the past, maybe 100 years ago, 3 children out of 1 would not reach puberty. But nowadays, I'm very sure that this child mortality rates have gone significantly lower. Food security, which is very important. I mean, for us, we are living a developing or almost developed country. So for us, even for us, food security is not an issue. But for underdeveloped countries, such as Africa or African countries or certain Asian countries, food security is a big issue. Respecting the view of beneficiaries and victims of development. What does it mean? For instance, imagine that you need to build a dam, barrage in Turkish, in order to make sure that energy and water supply in a region can be ensured for the next 30 years. But for building this dam, maybe you need to destroy an entire village because that village will be flooded by dam waters. So then you have to make sure that these people are compensated, and during the process you should also hear them out. You should not do this just because it is necessary. The public should always be part of the decision-making process, directly in the form of a referendum or indirectly in the form of a parliamentary system. So sharing of information is critical. So what about the economic dimensions? From a macroeconomics point of view, large-scale operations of economy, overall production of goods, services, employment, money supply, inflation, national debt, and balance payments. From a microeconomics point of view, prices and production processes should be considered. For a sustainable economy, economic well-being should be continuously improved. Economic well-being is a debatable issue because the question is, how do you define economic well-being? If the GDP increases, GDP is gross domestic product or gayri safi yurt içi hasıla. If it increases, does it mean that the economic well-being is being improved? Yes or no? I mean, I wouldn't say no directly, but an increase in GDP does not necessarily mean that the economic well-being is being improved, because as much as the GDP itself, its distribution is also important. Creation of new markets for growth is another important economic dimension. There's a typo in the first slide, at the title of the slide. Dimension should be written with an S, not a T. My mistake, I'm sorry. Investments in infrastructure and greater economic equality, as I told you earlier. So these are the economic dimensions. Some of the economic dimensions, so we need to go on. Efficient use of renewable resources, cost reduction through efficiency improvements, renewable energy and raw material input, especially important in regards to the overlap between economy and the environment, creation of value-added products, production of commercial rights, reducing international trade barriers, green business opportunities, accountability and responsibility of economic decision makers, sharing of commercial information, transparency of thought and planning process, participatory approach in developing economic policies, fair and equal access to information and knowledge. So as I told you earlier, GDP is an indicator of the economic output, but it's not the only indicator. We have to consider unemployment rate, distribution of income, sectoral distribution of jobs, distribution of housing, median value for land, net change in the number of jobs, age distribution, vacancy rate in housing and commercial sector are some of the important economic indicators. And now what about the environmental dimensions? Environmental concerns are similar everywhere. Well, economic concerns or social concerns can be very different in different countries because they are at different levels. So what is important from an economics point of view can be different in a country in Africa or in United States of America. But environmentally speaking, everywhere we have the same situation. If the environment is going to be damaged, it's going to be damaged the same way everywhere on Earth. I mean, building a dam will have the same impact. Using fossil fuels will have the same impact. That is why environmental dimensions are universal, not regional. So when we say environmental impacts, we should consider abiotic, which means physical or non-living, and biotic sources. Abiotic sources are, for instance, metals, minerals. Biotic sources are fossil fuels. So we need to consider the impacts on air, we need to consider the impacts on the soil, we need to consider the impact on the water. So this is a very nice slide. In this slide, you can see some main environmental impacts. I'm not expecting you to memorize everything that is written here, but you should remember the important ones. So global warming is caused by greenhouse gases, the most important of which is carbon dioxide. We have ozone depletion, which was very popular, I would say, when I was growing up. In those days, people would always talk about ozone depletion and how it would affect our lives. Global warming was not much of an issue back then, but nowadays, global warming has become much more critical than ozone depletion. Ozone depletion is dangerous because the ozone layer in the atmosphere minimizes the UV radiation reaching the Earth's surface. If the ozone layer is depleted, more and more ultraviolet UV radiation will reach the surface of the Earth, and it will cause skin cancer and other health impacts on humans. Acidification is the increase of acidity in soil and in water, and it's caused by sulfur dioxide and nitrogen oxide emissions as a result of fossil fuels, most importantly coal and petroleum. Eutrophication is the increase of organic material in water due to agricultural activities or food production processes. Photochemical smoke is what we know as air pollution. Photochemical smoke is the scientific name of air pollution. It is mostly due to the use of fossil fuels for central heating in our houses, and also use of fossil fuels for transportation in urban locations. It causes health impacts, respiratory impacts, most importantly. Toxicity in the form of terrestrial toxicity, aquatic toxicity is the release of any toxic chemicals to the soil or to water. For instance, when we use pesticides, böcek ilacı in Turkish, to maximize the growth of agricultural products, we are also negatively affecting the soil and also the water, because some of those pesticides can mix with the underground water resources. So we should not sacrifice the environment just to maximize the economic output today. Because if you want to obtain just 10% more vegetables from your field, and to do that if you use a lot of herbicides, then you would be sacrificing the futures, because in the future generations will not be able to use that land for agricultural production. Human health, it is what we call endpoint impact. All the impacts so far were midpoint impact, so they have further impacts, but human health is an endpoint impact, so it is the further impact itself. Resource depletion is another further or endpoint impact. Land use and water use are self-explanatory, so I don't need to explain them. So I would like you to pay attention to this particular slide while studying for this chapter. So what factors or what elements should be considered in sustainable developments? Renewal of natural resources and natural systems, renewal of energy, renewal of materials, renewal of food resources. Reduction of environmental footprints, accountability and responsibility of environmental decision makers, sharing of vital information on global environmental changes. Transparency of thought and planning process, participatory approach in environmental protection. We should consider that some environmental issues originate from social factors, so we cannot avoid all environmental impacts. For instance, as populations will increase, we will need more and more central heating, for instance. So since we cannot allow people to live in cold buildings, we will have to heat those buildings, and as a result, we will have to release carbon dioxide into the atmosphere as a result of fossil fuel utilization. So we have to, first of all, quantify these impacts, and then we need to do whatever we can to minimize these impacts. So reducing them is possible, removing them altogether or getting rid of these impacts is unrealistic. So we can achieve this by minimizing the waste or using the waste, recycling and reusing. These are the futures of our world. Maybe at this stage I should also mention circular economy a little bit. I mean, you may have heard of this phrase before, circular economy. It's a very popular phrase, But just like innovation, people use this phrase all the time without actually knowing what it means. Circular economy is the opposite of linear economy. In linear economy, we produce something, we use it, and we get rid of it. And then the production begins all over again. In circular economy, we either recycle the material or we reuse the material. So there is a circle. We go back to the previous stage. Instead of a line, we have a circle in a circular economy. So the critical words here are recycling and reusing. Recycling in Turkish geri dönüşüm, reusing yeniden kullanım. So reusing is a very new concept. In some Western countries, for instance, now certain food products are sold in reusable packaging. What you do is you buy this product from the market, you use it, you eat the food inside, you don't get rid of the packaging material, you come back to the store and then you get the same product into the same packaging again. You don't use a fresh piece of packaging, you use the same one again. This is especially suitable for dry goods rather than cooked food. So this is an example of reuse. In the near future, this could also be seen in other industries as well. Other indicators are percentage of population that doesn't have access to sewage systems, percentage of prime agricultural land, percentage of population using public transportation or carpooling, households participating in recycling programs, tons per capita of solid waste generated annually, tons of hazardous waste generated annually, tons of toxic releases annually, number of environmental education classes in public and private academic institutions. So these should be quantified in order to understand the level of sustainable development in a country. These numbers can give you a very good idea, not by themselves, but when considered as a whole. And now this brings us to the next discussion, this sustainability metrics. So how do we measure sustainability? To do that, we need indicators. There are many different indicators. Again, they are divided into three main groups: social, economic, and environmental indicators, but there are several different ones. The Environmental Protection Agency, or shortly EPA in the United States, suggested 4 categories, which are as follows. Adverse outcomes indicators. These are negative indicators. Adverse means negative in English. So destruction of value due to impacts on individuals, communities, business enterprises, and natural environment. Resource flow indicators indicates pressures associated with the rate of consumption resources, such as material, land, and energy, water. System condition indicators indicate the state of the system in question, individual, communities, business enterprises, natural environment. And finally, value creation indicator indicates the creation of value, both economic and well-being, through enhancement of individuals, communities, business enterprises, and natural environment. So one example is Human Development Index that is calculated according to United Nations criterion. It's a composite statistics that considers life expectancy, education, and per capita income indicators. So it uses several different data to combine one index, and it is published every year. So here you see the situation in the world regarding Human Development Index. Basically, dark blue is the best, then comes blue, light blue, and the color goes towards light blue or white. Unfortunately, Human Development Index reduces. So the best countries, I'm sorry, there are a few typos in this slide, my mistake. Norway, Australia, Switzerland, Netherlands, United States, they rank high. And the ones that are low, as you can see, they are all in Africa, unfortunately. Sierra Leone, Chad, Congo, and Niger. So another important index is life expectancy index. So how long should a member of a society be live? Education index is another important index. We also use purchasing power per capita, paranın satın alma gücü, as you may have heard it. Sometimes it's also called the Big Mac index. If you don't know what Big Mac index is, I strongly suggest you to look it up in Google. So these are some examples of indicators. So Challenges for sustainable development. So we have mentioned these, we have mentioned the challenges that we face as humans in the future. But in this part, we are going to discuss the challenges that we specifically need to consider that would prevent us from achieving our sustainability goals. There are technical barriers. I mean, knowing how something can be done is one thing. Being able to do it is something else. I'm going to give you one example. If you remember from earlier slides, I said that sulfur dioxide emissions as a result of fossil fuel combustion causes acidification. And the worst type of fossil fuel that you can think of is coal, especially lignite, which is a low quality type of coal that we have in Turkey. Turkey is a rather unfortunate country when it comes to fossil fuel resources. The only significant amount of resource that we have is lignite, which is found mostly in Central Asian region, in Manisa, Kütahya, in Soma region especially, Tunçbilek. And when we burn lignite to produce energy, we release lots and lots of sulfur dioxide into the atmosphere because of the high sulfur content of lignite. Is there a way to avoid this? Yes, we can use filtering systems. For instance, I'm not going to again go into the detail of the chemistry, but if you use calcium carbonate filters, these will calcium carbonate will react with sulfur dioxide to form calcium sulfate, which is known as gypsum, alçataşı. It is used in many different industries as a raw material. So you will not only get rid of those hazardous emissions, but you would also obtain a useful byproduct. So it's a win-win. So why don't we do it then? Well, it's not easy to do it. I mean, it's easy to say it, but it's not easy to do it because there are several technical challenges. The main technical challenge in this example is the power plants in our country have been built many years ago and they are not suitable for such filtering systems. In order to install those filtering systems, we need to make lots and lots of investment. So that is one example of a technical barrier. But it's also a sort of an economic barrier. So we can do it, not with the current technology, we need some modification, but we can do it at the end, but then it would cost a lot. And in some cases, there are institutional barriers. They may not be regulations. In Turkey, for instance, there is no carbon markets. In many countries in Europe, in certain states in America, such as California, there are carbon markets. In Turkey, we don't have a carbon market. So without a carbon market, carbon trade, which is an effective way of reducing carbon dioxide emissions, cannot function. So this is an example of an institutional barrier. Behavioral barriers. Now, this is, in my opinion, the most difficult one. You can overcome technical barriers. You can overcome economic barriers. You can overcome institutional barriers, but overcoming behavioral barriers is quite difficult. Because people are not likely to change the way they behave. They don't want to get rid of their comfort zone. I mean, people should not use personal transportation. People should be encouraged to use public transportation to promote sustainability. But for many people, instead of driving your own car, getting on the bus or using the subway is not preferable. They prefer luxury. And that is perfectly understandable. I mean, I cannot criticize people for doing that. I myself drive to work from home every morning. I could use public transportation. I don't. This is an example. What I do actually is harmful to the environment, but I keep doing it. And similar examples can be given. Another important issue, meat. It has been proven that eating meat harms the environment in many different ways. So meat is not sustainable. So to achieve a more sustainable future, we must minimize the amount of meat that we eat. I'm not saying that we shouldn't eat meat altogether, but we should decrease the amount of meat that we eat. But for many people, this is a taboo. when you say people you should at least less meat, they react as if you pulled a gun on them. I mean, that is an example of behavioral barrier because people love eating meat, which is understandable, but they don't want to give it up. So certain barriers are difficult to overcome. Intergenerational equity, that is also difficult. How are we going to decide which sources are more important for today, which sources are more important for the future? Substitution of resources. So if you're going to substitute something, how are we going to do it? If you're going to replace a resource by something else, how are we going to do it? That is the question here. And there are always uncertainties and reversibilities. I mean, the best example of uncertainty that we can think of is the current COVID pandemic in which we are living right now. I mean, no one could have estimated this 1 year ago. And now many aspects of our lives have changed. Some of them, hopefully, temporarily, things will go back to normal once this pandemic is over. But some of them may stay for good. So some of our lifestyle may have changed permanently. This is an example of uncertainty. You can never know when such things will happen. Uncertainty means pandemics, wars, things like that. And the last topic, before I would like to finish this presentation, is multilateral environmental agreements, or MEAs. These are agreements that are signed by many different countries so that these countries come together to act in a combined fashion to reduce certain environmental impacts or to promote sustainability, to promote economic growth all around the world. So there are many different examples of these. One thing that you should know about MEAs is MEAs cannot be enforced. So if a country does not want to be a part of an MEA, you cannot force them. And the biggest question of an MEA is, if a country does not obey the rules, how do you punish that country? For instance, do the other countries declare war against that one? Obviously not. Usually the punishment in this case comes in the form of an economic punishment. But if the country is too strong, then basically no one can punish that country. But one example to this is actually here, let me see. In one of these slides, I should be mentioning the Paris Accord. Yeah, here in this slide, I will go back to the previous slides in a few minutes. So here you see Kyoto Protocol, which was signed in 1997, and then almost 20 years later, an updated version of Kyoto Protocol was signed in Paris, and it was called Paris Accord. It is a joint effort by almost all countries in the world to reduce greenhouse gas emissions. United States of America, is one of the countries that initially signed this accord, because back then Barack Obama was the president of America, and after a few months, Donald Trump was elected as president, and he said he will leave the Paris Accord. That is because he thought that Paris Accord damages the American economy. In some ways, it would, because Paris Accord encourages the use of renewable resources and minimizes the use of fossil fuels. And fossil fuel economy is very big in America, especially in certain states such as Texas. There are lots of oil companies. And in certain states such as Pennsylvania, coal industry is very big. Therefore, if American economy, if the American government would reduce the amount of energy produced from fossil fuels, these states would be, at least in the short run, would be likely to suffer economically from these changes. So Donald Trump said, we are leaving the Paris Accord, and that was it. Nobody could do anything about this because, I mean, it is America we are talking about. How are you going to punish America? So they can basically get away with these things, but for less powerful countries, it could be there could be some sort of economic punishment, maybe in the form of a boycott or an embargo. So if you go back to the slides, so some of the main principles of these MEAs is that the polluter pays. So which requires all pollutions to be monitored regularly. There should be no discrimination, and we should always make precautions, and we shall not use lack of scientific means as an excuse. Therefore, more developed countries were asked to help less developed countries with their scientific development, so that scientific development, scientific opportunities can be equally accessible to all countries all around the world. Principle of common differentiated responsibilities, which means nations should divide the cost on measures to protect the environment. Principles of intergenerational equity, we have mentioned this earlier, but these are the important aspects of MEA. So that's all I would like to say about this issue. I hope you found this interesting. Sustainability is a very important topic. So right now I just try to summarize this in more or less one lecture, but actually we could have a separate course dedicated to sustainability only, a full semester course. Maybe in the near future we will design a course, maybe in undergrad level or postgrad level. So if you see such a course, well, you are all about to graduate right now, so I don't think you will be here much longer with us. But if you see such a course somewhere, maybe later when you do master studies, if you can please take a sustainability course, it will help you and it will broaden your horizon significantly. You will benefit from this. I can assure you of that. So that's all I would like to say. I would like to thank you for listening and wish you the best of luck. Thank you.